Because event-driven systems using CQRS can get very large and very complicated, you're eventually going to come to have to face a problem with using one data model. From a legacy perspective, it's very common for any given industry, whether cars or airline or some sort of transportation, to go through an effort which we'll sometimes refer to as one model to fit them all. And a good example of this, and I'll use airlines as an example, we have a lot of data, but how people access that data is complicated, it's slow. So what we're going to do is we're just going to create a single database schema to represent all the needs everyone could ever have for an airplane. Whether crew scheduling or continuous fluid dynamics or billing, we're just going to have one series of tables and schemas that people can access to deal with this. This sometimes sounds like a great idea, but in reality, this always fails. That's because in order to now get billing information, I now have to contend with the fact that I have a ton of these different continuous fluid and physics models tables that are built into it. It makes the querying so big and so unrealistic that these projects always fail. People get fed up, they go and create their own models of the data, and so on. This is because one model can't fit them all, and by trying to tightly couple all these different domains together, you're essentially inviting a lot of complexity, and it also makes minor changes impossible. I now can't come in and add a column to what I needed for the billing and sales cycle because for some reason, since we're using the same airplane model, it's causing all the physics modeling to now fail because they're using different schemas. So this will generally result in shifting either intentionally or unintentionally to the domain-driven model. And domain-driven design, instead of having one model, the idea is that it's okay to have redundant data, different representations of an underlying data set in multiple places. This is the sales data, this is the billing data, this is the engineering data. And where eventing comes in is that keeping this data in sync is otherwise impossible. If you're having to rely on all these manual processes to update A to B to C to D, and sometimes people will attempt to do this, you end up with a data architecture that's very hard to maintain. And so where eventing can make this easier is the idea of the event bus is the actual source of truth, is that as long as everyone's reading from the same event bus with the same events, this is a billing update, this is an engineering update, this plane just landed, everyone's processing the same raw data and using it to assemble their model. There's no having to go out and manually fetch a billing update or a physics model update or a plane design update. It's all on the same event bus, and you only have to pull the events that your domain specifically needs. If I'm doing nothing but sales, I don't care about some of those engineering details. I'm interested in how many planes are being purchased and tickets are being sold and whatever. So you can focus only on the events you need. And as I've mentioned, this really is going to be in place whether you realize it or not. Because of the nature of the conflicting needs of the different domains for operating any model, whether a train, plane, or automobile, you're going to have different data domains. It's a matter of whether you want to acknowledge it or not, and it's a matter if you want to truly be able to keep it in sync or relying on all these independent custom processes to do so from different varying data sources.